The Sun, our celestial engine. Our solar system begins with the Sun. It is a star, a rather ordinary star in the grand cosmic scheme. But for us, it is everything. The Sun sits right at the heart of our cosmic neighborhood. All the planets, including our Earth, dance around it. They follow paths called orbits, held by the Sun's immense power. This star is not just a bright light in the sky, it is the anchor, it is the sustainer, it is the reason we have a solar system at all. Its sheer size dwarfs everything else around it. The Sun shines because it is a giant nuclear furnace. Deep within its core, incredible pressures and temperatures exist. These conditions force hydrogen atoms to fuse together. They become helium atoms. This process is called nuclear fusion. When this happens, a tiny bit of mass is converted into a huge amount of energy. This energy travels outwards. It journeys for thousands of years within the Sun. Then it bursts forth as light and heat. This light and heat stream across space, warming the planets. The Sun's gravity is the great organizer of our solar system. Gravity is the force of attraction between all objects that have mass. The Sun is incredibly massive. It contains more than 99.8% of all the mass in the entire solar system. This gives it a powerful gravitational pull. This pull reaches out for billions of miles. It grasps onto every planet, every asteroid, every comet. It keeps them bound in their orbits. Without the Sun's gravity, the planets would wander off into the cold, dark emptiness of interstellar space. For life on Earth, the Sun is absolutely vital. It is our ultimate source of energy. Plants use sunlight to make their food through photosynthesis. This process forms the base of most food chains on our planet. The Sun's heat keeps Earth's temperature stable enough for liquid water to exist. Liquid water is essential for life as we know it. The Sun drives our weather patterns and ocean currents. It dictates our days and our seasons. We owe our very existence to this magnificent life-giving star. It is our celestial engine powering everything. The inner solar system, worlds forged in fire. Closer to the Sun, we find the inner solar system. This region is home to 4 special planets. They are Mercury, Venus, Earth, and Mars. These are often called the terrestrial planets. The word terrestrial means Earth-like. This is because they are primarily made of rock and metal. They have solid surfaces you could, in theory, stand on. This makes them very different from the giant planets found further out. These inner worlds are relatively small and dense compared to their larger siblings. These 4 planets formed in the hotter inner part of the ancient solar nebula. This was the vast cloud of gas and dust from which our solar system was born. Closer to the young Sun, temperatures were too high for lighter gases like hydrogen and helium to condense easily. Instead, heavier elements like iron, silicon, and oxygen came together. They clumped to form these rocky worlds. Their proximity to the Sun means they receive much more intense solar radiation. This significantly shapes their environments and their histories. Each inner planet tells a unique story. Mercury is the smallest and closest to the Sun. Venus is a hothouse, shrouded in thick clouds. Earth is our vibrant, life-filled home, a blue marble. Mars is the cold, red desert world, holding clues of a wetter past. While they share common origins as rocky bodies, their evolutionary paths have diverged dramatically. Studying them helps us understand how planets form and change over billions of years. It also helps us appreciate the delicate balance that makes Earth so special. The inner planets are not alone in their orbits. Some have moons. Earth has 1 large moon. Mars has 2 very small, asteroid-like moons. Mercury and Venus have no moons at all. The space between these planets is not entirely empty either. It contains dust and occasional asteroids. These small worlds are our closest planetary neighbors. They are the most accessible for exploration. We have sent many robotic missions to study them up close. Each visit reveals more about these fascinating worlds forged in fire. Mercury and Venus, tales of fire and fury. Let's journey to Mercury first. It is the swiftest planet, zipping around the Sun in just 88 Earth days. Being so close to our star, Mercury faces extreme conditions. Its sun-facing side can reach scorching temperatures, hot enough to melt lead. Yet because Mercury has almost no atmosphere to trap heat, its night side plummets to incredibly cold temperatures. This tiny world is covered in craters, scars from ancient impacts. It looks a lot like Earth's moon. It also has a surprisingly large iron core, making up most of its interior. Next is Venus, often called Earth's twin because it is similar in size and mass, but the resemblance ends there. Venus is a hellish world. It is permanently shrouded in thick clouds of sulfuric acid. Its atmosphere is incredibly dense, mostly carbon dioxide. This has led to a runaway greenhouse effect. Surface temperatures on Venus are even hotter than on Mercury. They are hot enough to melt lead all over the planet, day and night. The atmospheric pressure at its surface is crushing, over 90 times that of Earth's. These two planets also have peculiar rotations. Mercury rotates very slowly, taking about 59 Earth days to spin once. This means its day is very long. Venus rotates even more slowly, and it spins backwards compared to most other planets, including Earth. This is called retrograde rotation. Why it spins this way is still a bit of a puzzle. Perhaps a giant impact in its distant past knocked it askew. These unique characteristics make Mercury and Venus fascinating subjects for planetary scientists. Exploring Mercury and Venus is extremely challenging. The intense heat and harsh conditions make it difficult for spacecraft to survive for long, especially on Venus's surface. Despite these difficulties, missions like NASA's Mariner 10 and Messenger to Mercury and the Soviet Venera landers to Venus have given us valuable insights. They have mapped surfaces, analyzed atmospheres, and measured magnetic fields. Each piece of data helps us understand these extreme worlds, offering lessons about planetary evolution and climate change that are relevant even here on Earth. Earth and Mars, oases of possibility. Earth is our home. It is a truly special place in the solar system. It is the third planet from the Sun. This location is often called the Goldilocks zone. It is not too hot and not too cold. It is just right for liquid water to exist on its surface, and liquid water is a key ingredient for life as we know it. Earth has vast oceans of water. It has a protective atmosphere rich in nitrogen and oxygen. It also has a strong magnetic field. This field shields us from harmful solar radiation. These conditions have allowed life to arise and flourish here for billions of years. Then there is Mars, the fourth planet. It is often called the red planet. This is due to the iron oxide, or rust, on its surface. Mars is smaller than Earth. It is also colder and has a much thinner atmosphere. This atmosphere is mostly carbon dioxide. Today, Mars is a dusty desert world, but we see strong evidence that it was different in the past. Features like dry riverbeds, ancient deltas, and minerals that form in water suggest Mars once had liquid water flowing on its surface. It might have been a warmer, wetter place. Comparing Earth and Mars is like looking at two siblings who took different paths. Both are rocky planets in the inner solar system. Both show signs of geological activity. Earth remained a haven for life. Mars, however, lost most of its atmosphere. Its water either froze at the poles and underground or escaped into space. Understanding why Mars changed so dramatically is a major goal of planetary science. Did life ever arise on Mars? Could it still exist there, perhaps hidden beneath the surface? These are exciting questions. The search for answers drives our exploration of Mars. We have sent orbiters, landers, and rovers to study it. Rovers like Curiosity and Perseverance are like robotic geologists. They analyze rocks and soil. They look for signs of past or present microbial life. The dream of sending humans to Mars is also very much alive. Such a mission would be a monumental undertaking, but it could unlock profound discoveries about our neighbor planet. And perhaps it could tell us more about the potential for life beyond Earth. Section 5. The Gas Giants, Jupiter and Saturn's Grandeur. Beyond Mars and the asteroid belt lie the gas giants. These are Jupiter and Saturn. They are colossal worlds, vastly different from the inner rocky planets. Jupiter is the undisputed king of the planets. It is more massive than all the other planets combined. Its immense size creates powerful gravitational forces. Jupiter is famous for its colorful bands of clouds and the Great Red Spot. The Great Red Spot is a gigantic storm, larger than Earth, that has been raging for centuries. It also has a very strong magnetic field. Saturn is the second largest planet. It is perhaps the most beautiful object in our solar system. This is thanks to its magnificent system of rings. These rings are not solid. They are made of countless particles of ice and rock. These particles range in size from tiny dust grains to a few as large as mountains. Saturn itself is a pale, yellow, banded world. It is the least dense planet in our solar system. In fact, if you could find a bathtub big enough, Saturn would float in water. Like Jupiter, it spins very rapidly. These two giants are composed mainly of hydrogen and helium. These are the lightest and most abundant elements in the universe. They are the same elements that make up the Sun. Deep inside these planets, the pressures are so immense that hydrogen can behave like a liquid metal. This is thought to be the source of their powerful magnetic fields. Unlike the terrestrial planets, Jupiter and Saturn do not have solid surfaces. What we see are the tops of their deep, turbulent atmospheres. They are truly worlds of gas. Jupiter and Saturn are like mini solar systems themselves. They are orbited by a multitude of moons. Jupiter has dozens, including the four large Galilean moons, Io, Europa, Ganymede and Callisto. Each is a fascinating world in its own right. Saturn also has many moons, including the large moon Titan. Titan has a thick atmosphere, even denser than Earth's, and lakes of liquid methane and ethane on its surface. Studying these gas giants and their moons helps us understand planetary formation on a grand scale. Section 6. The Ice Giants, Uranus and Neptune's Frigid Realm. Moving further out into the cold depths of the solar system, we encounter the ice giants. These are Uranus and Neptune. They are smaller than the gas giants, Jupiter and Saturn, but they are still much larger than Earth. Uranus is the seventh planet from the Sun. It has a unique feature. It is tilted on its side. Its axis of rotation is tilted by about 98 degrees. This means it essentially orbits the Sun, rolling on its side. This extreme tilt results in very unusual seasons on Uranus, with each pole experiencing decades of continuous sunlight followed by decades of darkness. Neptune is the eighth and farthest known planet from the Sun. It is a deep blue world, similar in size to Uranus. Its vibrant blue color, like Uranus's blue-green hue, comes from methane gas in its atmosphere. Methane absorbs red light and reflects blue light. Neptune is known for having the fastest winds in the solar system. These winds can reach speeds of over 1,200 miles per hour. For a time, Neptune had a prominent storm called the Great Dark Spot, similar to Jupiter's Great Red Spot. However, these spots on Neptune seem to be more transient. The term ice giants refers to their composition. While they do have thick atmospheres of hydrogen and helium like Jupiter and Saturn, they contain a much higher proportion of heavier elements. These elements are found in the form of ices such as water, ammonia, and methane. These are not necessarily frozen solid like ice on Earth. Deep within Uranus and Neptune, these ices exist under extreme pressures and temperatures. They form a hot, dense, fluid mantle around a small, rocky core. These worlds are incredibly cold at their cloud tops. Our knowledge of Uranus and Neptune is more limited compared to other planets. Only one spacecraft, Voyager 2, has flown past them. That was back in the 1980s. That brief flyby provided most of the close-up images and data we have. There is still much to learn about these distant, frigid worlds. Future missions to the ice giants are being planned. Such missions would help us understand their complex atmospheres, strange magnetic fields, and numerous moons and rings. They hold clues to the outer reaches of our solar system. Section 7. Cosmic debris and companions, moons, asteroids, comets. Our solar system is not just planets and the Sun, it is filled with a vast array of smaller objects. Moons, also known as natural satellites, orbit planets. Earth has one large moon. Our moon plays a crucial role. It stabilizes Earth's axial tilt, giving us more stable seasons. Its gravity causes ocean tides. Most other planets also have moons. Some are small, captured asteroids. Others are large, geologically active worlds. Jupiter and Saturn, for example, have dozens of moons each, forming complex systems. Some moons are particularly fascinating. Jupiter's moon Europa is covered in a thick shell of ice. Scientists believe there may be a vast saltwater ocean beneath this ice. This ocean could potentially harbor life. Saturn's largest moon, Titan, has a thick, nitrogen-rich atmosphere. It even has rivers, lakes, and seas of liquid methane and ethane on its surface. Jupiter's moon Io is the most volcanically active world in the solar system. Its surface is constantly reshaped by hundreds of volcanoes spewing sulfur. Ganymede, another of Jupiter's moons, is the largest moon in the solar system, even bigger than the planet Mercury. Between the orbits of Mars and Jupiter lies the main asteroid belt. This region is populated by millions of rocky objects called asteroids. They range in size from pebbles to dwarf planets like Ceres, which is about 600 miles in diameter. The asteroid belt is thought to be made of material that never managed to form a planet. This was likely due to Jupiter's strong gravitational influence. Asteroids are like cosmic fossils. They are remnants from the early solar system, offering clues about its formation and history. Comets are another type of small solar system body. They are often described as dirty snowballs. They are composed of ice, dust, and frozen gases. Most comets originate in the very distant, cold outer regions of the solar system. Some come from the Kuiper Belt, a region beyond Neptune. Others come from the even more distant Oort cloud, a spherical shell surrounding the solar system. When a comet's orbit brings it close to the sun, the solar heat vaporizes its ices. This creates a glowing coma, or atmosphere, and often one or two tails that can stretch for millions of miles. Section 8. Gravity, the universe's sculptor. What holds this magnificent solar system together? The answer is gravity. Gravity is one of the fundamental forces of nature. It is the force of attraction that exists between any two objects that have mass. The more massive an object is, the stronger its gravitational pull. The closer two objects are, the stronger the gravitational force between them. This simple, universal rule governs the motions of everything in the cosmos, from falling apples on Earth to a galaxy's majestic swirl. It is the universe's primary sculptor. The Sun, being by far the most massive object in our solar system, exerts the dominant gravitational force. This immense gravity is what keeps all the planets in their orbits. Imagine trying to swing a ball on a string around your head. Your hand is like the Sun. The string represents gravity. The ball is a planet. Without the string, gravity, the ball would fly off in a straight line. Similarly, without the Sun's gravity, the planets would drift away into space. The planets move in elliptical paths, not perfect circles, continuously falling towards the Sun, but always missing due to their sideways motion. Gravity doesn't just operate between the Sun and planets. Planets themselves have gravity. This is why they can hold onto moons. Earth's gravity keeps our moon in orbit around us. Jupiter's strong gravity controls its large family of moons. Gravity also played a crucial role in the formation of the planets and moons themselves. In the early solar system, tiny dust particles and gas molecules were pulled together by gravity. They clumped to form larger and larger bodies. And eventually these grew into the planets and moons we see today. Gravity even shapes these bodies into spheres once they become massive enough. The story of our solar system's birth is a story of gravity at work. It began with a vast, slowly rotating cloud of gas and dust, the solar nebula. Gravity caused this cloud to collapse. As it collapsed, it spun faster and flattened into a disk, much like a spinning pizza dough. Most of the material fell to the center, forming the Sun. The remaining material in the disk gradually coalesced into planets, moons, asteroids, and comets. Gravity orchestrated this entire cosmic construction project, building our solar system from primordial stardust. It continues to shape its destiny. Section 9. Our place in the cosmos, the ongoing quest. Why do we study the solar system? What drives our curiosity about these distant worlds? The answers are as profound as the universe itself. Studying our solar system helps us understand our origins. It tells us about the processes that formed our Sun, our Earth, and ultimately, us. By looking at other planets, we learn about the conditions that can lead to different planetary fates. We see worlds that are too hot, too cold, too hostile for life as we know it. This gives us context. It helps us appreciate the delicate balance of factors that make Earth a habitable oasis. Our exploration of the solar system puts Earth into perspective. It is a single, small blue planet in a vast cosmic arena. Seeing Earth from space, a pale blue dot, as Carl Sagan called it, evokes a sense of wonder and humility. It underscores the interconnectedness of life on our world and the importance of protecting our home. The solar system is our immediate cosmic backyard. Understanding it is the first step in understanding our place in the wider universe. It allows us to ask bigger questions about the cosmos and our connection to it. One of the most compelling reasons to study the solar system is the search for life beyond Earth. Are we alone in the universe? This is one of humanity's oldest and most profound questions. Within our solar system, places like Mars, Europa, and Titan hold tantalizing possibilities. Mars may have harbored life in its past, or perhaps it still does, hidden beneath the surface. Europa's subsurface ocean could be a habitat for life. Even Titan, with its exotic chemistry, pushes us to think about life in forms we haven't yet imagined. The discovery of life elsewhere, even microbial, would revolutionize our understanding of biology and our place in the cosmos. The journey of exploration is far from over. Each new mission, each new discovery peels back another layer of mystery. We continue to send robotic explorers to gather data. We dream of sending humans to Mars and beyond. The study of our solar system is a continuous quest for knowledge. It fuels our imagination, inspires future generations, and expands our understanding of what is possible. It tells us that we are part of something much larger, a grand cosmic narrative still unfolding. And our curiosity compels us to keep reading its chapters.